Sup fuckers, today we got yet another math problem. So we're supposed to prove this thing here. So 1 squared, just 1, minus 2 squared plus 3 squared minus so forth, all the way up to plus or minus n squared is equal to minus 1 to the power of n plus 1 times n plus 1 over 2. So firstly, I'm just gonna rewrite this thing here with some notations instead. So basically what we're gonna do here is that, okay, we have the sum where k goes from 1 to n of minus 1 to the power of, okay, so 1 should be positive, so therefore n plus 1 times k squared is supposed to be equal to minus 1, sorry, it should be k here, k plus 1 minus 1 to the power of n plus 1. And what is that? That is just sum where k goes from 1 to n k. So this is our simplified shortened version. So to prove this, we shall use induct. So firstly, we just try a really simple case, say where n is equal to 1 maybe. Yeah, then we just have, okay, we just input 1 everywhere, so we get a positive. 1 squared, which is just 1, and then n is 1, so this is positive. This becomes just a plus, so here 1 is equal to 1. Yes, good. N is equal to 1. Absolutely works. So then we make this thing here our induction assumption, and now we shall prove the equality for when n is equal to n plus 1. So we start with the left hand side. So what do we have then? Okay, we just change every n to n plus 1. So we have k ranges from 1 to n plus 1 of minus 1 to the power of k plus 1 times k squared. Okay, and now let's split this up into 2 because we want to be able to use the induction assumption. So therefore we extract the last term out of this. So we still have a sum, but now we don't want to ranges to n, k1, and it remains exactly the same inside. And then we add the last term. Okay, so when k is equal to n plus 1, that it's n plus 2, so therefore it's just n. So, and then we just add minus 1 to the power of n plus 1 squared. Yes, and according to our induction assumption, we can exchange this thing here to be minus 1 to the power of n plus 1 times the sum of just k, where k ranges from 1 to n, and then plus we obviously still have to add that. So yeah, just plus minus 1 to the power of n times n plus 1 squared. And now we go back to the previous note. So essentially what we want here is, okay, first we should extract a minus 1 to the power of n plus 1. So then of course we can just make this a minus and then add 1 up here. So that is good. So therefore now we want to prove that this thing here minus this is equal to the sum where k ranges from 1 to n plus 1. And does that make any sense? No, it does not, because I did it wrong. Sorry. We shouldn't have an n plus 1 here. We should just have an n, right? Because we're also changing that to be plus 1. So it should be here. So therefore this should have a minus sign in front. Okay, minus 1 to the power of n. We should have there. And here it should be a plus and no plus 1 there. Yes, exactly. So now is this minus that the sum where k ranges from 1 to n plus 1? And frankly it is, but it isn't that easy. So we just rewrite this as the thing we had previously, meaning that what we have here is minus 1 to the power of n times, okay, so we have n plus 1 squared minus n times n plus 1 over 2. And here we can see that we can, out of this, we can do a bit of a factorization. So we would have n plus 1 times n plus 1 minus n half, right? Because we extracted n plus 1. And so therefore this just becomes n half plus 1. And what is this equal to? Well, this is obviously, if you just multiply by 2 inside this and then divide by 2, you would obviously then just get minus 1 to the power of n times n plus 1 times n plus 2 over 2. And that is, of course, the sum where k ranges from 1 to n plus 1. So therefore, and also multiplied by the minus 1 to the power of n. Yes, so that was everything. Hope you followed along and appreciated the video. And check out the link, and I'll see you some other time. Bye bye.